Let f of x equal 2x plus 5 and g of x equal x squared minus 3x plus 2. Perform each operation and find the domain. So I'm going to start with f of x plus g of x. Just take what f of x is, 2x plus 5, and add on to that what g of x is, the x squared minus 3x plus 2. Go back through that and combine the like terms. Like terms would be 2x and negative 3x. If you combine those, it would be negative x. Also 5 and 2, if you combine those, that is 7. Now for the domain, you're looking for any restrictions, any square root signs, any fractions. There are no square root signs, no fractions, therefore no restrictions on the domain. So the domain will be the set of all real numbers. And if that was an equation, such as y equals x squared minus x plus 7, that would be the graph of a parabola, a U-shaped graph that opens upward. As that graph goes higher and higher, it's going to get wider and wider, using or consuming all x values in the construction of that graph. 3 times f of x minus 2. So take what f of x is, 2x plus 5, multiply it by 3, and subtract 2. Use a distributive property with that 3. Take 3 times 2x, that is 6x, and 3 times 5 would be 15. Don't forget you got a minus 2 on the end. Go back through and combine the like terms. 15 and negative 2, if you combine those, it would be 13. So that is 6x plus 13. Now for the domain, you're looking for any restrictions, any square root signs, any fractions, which there are none, therefore no restrictions on the domain. The domain would be the set of all real numbers. So the graph of that, if that was an equation, such as y equals 6x plus 13, the graph of that would be a line. As it goes higher and higher, lower and lower, it's going to get farther and farther to the right, farther and farther to the left, consuming or using all x values. That's why the domain is a set of all real numbers. So that is 6x plus 13, domain is all real numbers, and that is the graph of y equals 6x plus 13. We're finding negative 2 times g of x plus f of x. So take what g of x is, multiplied by negative 2, and then add on to that what f of x is. So take a negative 2 times x squared minus 3x plus 2, that is g of x, and add on to that what f of x is, the 2x plus 5. Use a distributive property with the negative 2. So take negative 2 times x squared, that is negative 2x squared, negative 2 times negative 3x, that is 6x, and negative 2 times 2, that is negative 4. And then you're adding on to that the 2x plus 5, or the f of x. Go back through and combine the like terms. Like terms would be 6x and 2x. If you combine those, that is 8x. Also negative 4 and 5, that makes 1. So the final result there is negative 2x squared plus 8x plus 1. Now when you state the domain, you're looking for any restrictions on the domain, the x values. So any square root signs, any fractions, those would cause the restrictions on the domain. There are no square root signs, no fractions, therefore no restrictions on the domain. So the domain would be a set of all real numbers. And if that was an equation, such as y equals negative 2x squared plus 8x plus 1, the graph of that would be a parabola. It's a U-shaped graph opening downward. As that parabola goes farther and farther down, it's going to get wider and wider, consuming or using all x values in the construction of that graph. Next, f of x over g of x. So take what f of x is, 2x plus 5, and divide that by what g of x is, the x squared minus 3x plus 2. So that is 2x plus 5 over x squared minus 3x plus 2. But when you're stating the domain, you want to see what values of x make that denominator equal to 0. So the best way to do that is to factor that denominator into two binomials. So that denominator will factor into x minus 2 times x minus 1. Now you can clearly see that if x was 2, that would make the denominator equal to 0. And if x is 1, that would make the denominator equal to 0 as well. So x cannot be equal to 2, and x cannot be equal to 1. So the domain would be the set of all real numbers except x cannot be equal to 1 and x cannot be equal to 2. Now the graph of that, you can see that graph does not hit 1 nor does it hit 2 on the x-axis because those are excluded from the domain. Taking negative 3 times f of x times g of x. So take negative 3 times what f of x is, the 2x plus 5, and multiply that by what g of x is, the x squared minus 3x plus 2. Use a distributive property with that negative 3. Take negative 3 times 2x, that is negative 6x, and negative 3 times 5, that is negative 15. To multiply these two, just use a distributive property. Distribute that negative 6x through that second set of parentheses, and distribute the negative 15 through that second set of parentheses, and then combine the like terms. So if you take negative 6x times x squared, that is negative 6x to the third. Negative 6x times negative 3x, that'd be 18x squared. And negative 6x times 2, that is negative 12x. Then distribute the negative 15 through that second set of parentheses. So negative 15 times x squared, that is negative 15x squared. Negative 15 times negative 3x, that'd be 45x. And finally, negative 15 times 2, that is negative 30. Go back through and combine the like terms. Like terms would be 18x squared and negative 15x squared. If you combine those, it's 3x squared. Also negative 12x and 45x. If you combine those, that is 33x. Still have a minus 30 on the end, and you still have that negative 6x to the third out front. So to state the domain, you're looking for any restrictions, any square root signs, any fractions, which there are none. So no restrictions on the domain. It'd be the set of all real numbers. You can see the graph of that. As that graph goes higher and higher, gets lower and lower, it's going to get wider and wider, consuming or using all x values. Next, f of x minus g of x plus 10. So take what f of x is, the 2x plus 5, subtract what g of x is, the x squared minus 3x plus 2, and then you're adding 10 onto that. Take out the parentheses and combine the like terms. Distribute that negative sign through the parentheses. So take the negative of x squared, that is negative x squared. The negative of negative 3x is positive 3x. And the negative of 2, that is negative 2. Don't forget, you have a plus 10 on the end and that 2x plus 5 out front. Combine the like terms. Like terms would be the 2x and 3x, that's 5x. Also 5, negative 2, and 10. If you combine those, that is 13. Don't forget your negative x squared out front. So negative x squared plus 5x plus 13, that is a quadratic. And the graph of that would be a parabola. So the domain would be all real numbers. It's a U-shaped graph opening downward. As that graph goes farther and farther down, it's going to get wider and wider, consuming or using all x values, all real numbers in the construction of that graph. For each pair of functions, find f of g of x and g of f of x. So if f of x is 3x and g of x is x squared, to find f of g of x, just take what g of x is, that x squared, and substitute that in for x into f of x. So it'd be 3 times x squared, and that is just 3x squared. That is f of g of x. Now to switch that around, g of f of x, take what f of x is, that 3x, and substitute that in for x into g of x. So it'd be the quantity 3x squared. 3x is inside parentheses, that's squared. Now if you square 3x, multiply it by itself, or you could just square the 3 and square the x, it's going to be 9x squared. Next, f of x equals 3x squared plus 2, and g of x is 2x. So to find f of g of x, take what g of x is, that's 2x, and substitute that in for x into f of x. So replace the x in f of x with that 2x. So it'd be 3 times 2x squared plus 2. Follow your order of operations, evaluate the exponent. So 2x squared, that would be 4x squared. So 3 times 4x squared plus 2. Multiply the 4x squared by 3, that is 12x squared plus 2. And that's as far as you can go with that. Next, g of f of x. So take what f of x is, that's 3x squared plus 2, and substitute that in for x into g of x. So it'd be 2 times 3x squared plus 2. Use distributive property with that 2. It would be 6x squared plus 4. Again, find f of g of x and g of f of x. This time f of x is x minus 3 over 2, and g of x is 2x minus 3. So to find f of g of x, take what g of x is, that 2x minus 3, and substitute that in for x into f of x. So replace the x in f of x with that 2x minus 3. So it'd be 2x minus 3 minus 3 in the numerator, all over 2. Just combine the like terms in the numerator, negative 3 and negative 3. If you combine those, that is negative 6. So it'd be 2x minus 6 all over 2. Try to simplify that if you can. You can see that 2 is a common factor in the numerator. So you could factor a 2 out of the numerator. It'd be 2 times x minus 3 all over 2. And then these 2's would cancel. So if you cancel those 2's, you're left with x minus 3. Now flip that around, g of f of x. So take what f of x is, the x minus 3 over 2, and substitute that in for x into g of x. So it'd be 2 times x minus 3 over 2 minus 3. Now when you're multiplying those, the 2's will cancel. So if you cancel the 2's, you have x minus 3 minus 3. And then combine the like terms, negative 3 and negative 3, that makes negative 6. So that would just be x minus 6. And once again, find f of g of x and g of f of x. For f of x equals negative x minus 7 and g of x equals 4x. To find f of g of x, take what g of x is, that is 4x, substitute that in for x into f of x. So be the negative of 4x minus 7. Watch your signs, because that is negative x in f of x. So that'd be negative 4x minus 7, and that's it. Nothing else to do there. Move on to g of f of x. So take what f of x is, the negative x minus 7, and substitute that in for x into g of x. So it'd be 4 times negative x minus 7. Just use the distributive property, and that is going to be negative 4x minus 28. Let f of x equal 1 over x and g of x equal x squared minus 2. What is f of g of negative 3? So first we'll find g of negative 3, and then we'll find f of that. So to find g of negative 3, go to what g of x is, that is x squared minus 2, and replace the x with that negative 3. So it'd be negative 3 squared minus 2. When you square negative 3, that is positive 9. That is 9 minus 2, and that is 7. So g of negative 3 is 7. Now we're going to find f of that. So to find f of 7, or in other words, f of g of negative 3, just replace the x in f of x with that 7. So it'd be 1 over 7, and that is letter B.